This is the Chapter 2, Part 2 review, which is going to be an explanation of each of the problems on your review packet. For these first two problems, you need to look at the type of graph that's being represented and determine a few things in order to write the inequality from the graph. So this first picture, you'll notice that you have a V-shaped graph. Remember, when you see a V, you should be thinking absolute value and vertex. So one of the first things I want you to do is identify what the vertex is in this picture. So I see there's my vertex, and I know the coordinates at that point are 1, 2, 3, 4. So my point is 1, 4. My vertex is 1, 4. Now the other thing that's super important for me to identify is my slope. Now if you notice what's happening on this graph is you're going up 1 and over 1 each time to get to a new point. So my slope is going to be 1 over 1, or just 1. Now when I write this inequality, I know I'm going to have absolute value bars with an x inside. And then what I'm going to do is I'm going to take my x coordinate of my vertex, and I'm going to place that in next to my x value within my absolute value bars. And remember, you have to switch the sign. So because I had positive 1 up here, now I have positive 1 down here inside the absolute value bars. Then I take the y value of my vertex, and I'm going to place that outside of my absolute value bars, plus 4. The last thing that I have to decide is my inequality symbol. So I'm going to look at my graph, and I see that I've shaded everything above my line. When I think above, I'm thinking greater than. Now the only other question I have to ask myself is, do I have a solid line or a dotted line when I look at my graph? Remember, a dotted line means I'm just going to have my greater than symbol, but a solid line means that I will have greater than or equal to. So because I do have a solid line, I need the or equal to bar on that inequality symbol. Now if I look at problem number 2, it's a very similar problem, except now I don't have a V, I simply have a line, which means I'm looking for something that's going to look like y equals mx plus b. Remember, m is your slope, so you have to identify your slope, and b is your y-intercept. So those are the two things that you're looking for in this case. I'm looking for my y-intercept, which I see is at 1, 2, 3, 4, 5, right there. My y-intercept is 5. So b equals 5 for this problem. And then my slope, if I'm looking at my line, I need to find where else it fits perfectly. Oh, well, they've given me 2 points here. They've given me this point here and this point here. Sorry about my dog. So here I have 2 points, and now I'm going to determine the slope between them by rise over run. So up 1, 2, 3, 4, 5, over 1, 2, 3, 4, 5, 6. So my slope is 5 over 6. Now when I write that into my equation, I have y. I'm going to leave a blank because I haven't figured out my inequality symbol yet. mx plus b. So I've inserted my slope. I've inserted my b value, just like what I had up here, y equals mx plus b. And then when I look at my inequality symbol, I have shading happening below my line. So below my line means less than. And I also see that I have a solid line. It's not dotted. So I'm just going to have the less than or equal to symbol. So this would be your answer for number 2. Back here, this was our answer for number 1. So for problems 3 and 4, we're looking at a specific kind of transformation called a reflection. Now in these problems, it asks only about a reflection in the x-axis, but I also want to get you practice for the y-axis as well, so I'm going to go through both of those. Now what's important, and what I'm going to start with, is making some notes. If we have a reflection in the x-axis, we are going to change all signs, all of the signs in the function. But if we are talking about reflection in the x-axis, we are only going to change signs on the x term. So if I go back and look at these two examples, let's say g of x is the x-axis for each 3 and 4. But then we're also going to change this problem just to get some more practice, and we're going to say that h of x is the y-axis. H of x is the y-axis, and we're going to do that for 3 and 4. So we get some practice with that as well. So for g of x, I'll use red. For h of x, I'll use green. G of x, I'm talking about the x-axis. So remember, x-axis, I'm changing all of my signs in the function. So if I look at f of x, I need to change all of my signs. So g of x equals negative 2x minus 10. Again, in number 4, g of x, I'm changing all of my signs, equals negative x squared minus 5. Now I'm going to switch to green. We're going to look at the y-axis. So h of x equals, now remember I'm looking back at my original function, and I'm only switching the sign in front of the x. So negative 2x plus 10 stays the same. In my second example, h of x equals negative x squared, but the plus 5 stays the same. So this is something very important to know for the test. This is just something you have to remember. Okay, this is what you need to remember, this right here. So the y-axis is going to be change only the x term. The x-axis is change all signs in the function. So for 5 and 6, we're looking at graphs. I need to create these graphs of these inequalities. The first one, I'm looking at this, and the first thing I see are these absolute value bars. Whenever you see absolute value, I want you to think V and vertex. So the first thing I'm going to do is identify my vertex. I know my vertex is a point, and I know that the values are going to come straight from my equation that I have. The first value, the x, is going to be this number inside my absolute value bars. I'm going to take the opposite of it, so negative 2. My second value is going to be exactly what is outside at the end, minus 3. So negative 2, negative 3 is my vertex. So I'm going to plot that point on my graph and go over negative 2. I'm going up, or I'm sorry, down to 3, 1, 2, 3. So right here is my vertex. That's negative 2, negative 3. Now when I'm graphing absolute value inequalities, the easiest way to graph this graph is to look at my vertex, which we've already done, we had it right here, and then look at my slope. Your slope can always be found right in front of your absolute value bars. So there I see there's nothing there. But there is an invisible 1. So I know my slope is just 1. Slope is 1. So from my vertex, I go up 1 over 1, point. Up 1 over 1, point. Once you have 3, that's good enough. If you want to create more, you can. Up 1 over 1, up 1 over 1. You could go on forever if you wanted to. We're going to stop there. Now, the second thing you're going to do is you're going to take those points and you are going to reflect them over the axis of symmetry. So I'm going to take each of these points, I'm going to reflect them over the axis of symmetry. Because I made a lot of points, I have a lot to reflect. There we go. So you can clearly see your V. But now before you connect your points, you need to consider what type of line you're going to use. So I look at my inequality symbol in my original problem. I see that I have a greater than symbol. it is missing the piece underneath, that straight line. So that means I need to be missing pieces of my line when I connect these points. So I'm going to have a dotted line. The other thing I have to determine is where I'm going to shade. My symbol is greater than. Greater than means I'm going to shade above. Remember, greater than is higher than is above, so I'm going to shade everything above that function. Okay, so that's the first one done. Second one, if I'm looking at number 6, I do not see absolute value bars. So because I don't see absolute value bars, I know that I'm going to have a linear function. Okay, it's just x and y. My issue, though, is that y is not by itself. So when I'm looking at this problem, oops, I need to make sure that I get x or y by itself. This is what I want alone. So what I'm going to do is I'm going to start solving this to get my y by itself. What that makes me do is move my x to the other side. So I'm going to add 2x to each side. Makes these go away. And I have negative 4y less than or equal to 2x plus 8. Now I still don't have my y by itself, so I need to divide by negative 4. Divide by negative 4, divide by negative 4. And when I do that, I cancel out on the left, so I'm left with y. But remember, I just divided by a negative, and when I divide or multiply by a negative, and I have an inequality, I have to flip my sign. So I have y is greater than or equal to. Now here I see 2 divided by negative 4. This is going to be a fraction. That's okay. But I do have to simplify this. So if I think about 2 and 4, I have a common factor of 2. 2 divided by 2 is 1. Negative 4 divided by 2 is negative 2. X. 8 divided by negative 4 minus 2. So this is now the inequality that I have to graph. So now I'm thinking about slope-intercept form. I see I have a couple of numbers that are important to me. Negative 2 is called my y-intercept, and negative 1/2 is my slope. So I'm going to go down to negative 2 on my y-axis, which is this axis right here. I go down to negative 2 and I put a point. Now to get some more points so I can actually draw my line, I'm going to use my slope. 1 over negative 2. So I'm going to go up 1 over 2 to the left. The same way of doing that would be down 1 over 2 to the right. So down 1 over 2 or up 1 over 2. I have some points. I'm going to connect these with a line. I look at my inequality symbol, and I see that I do have the or equal to bar. So because I do have this solid line beneath my sign, I'm going to connect each of these dots with a solid line. Sorry, that's not very straight. Your line should definitely be straighter than that. But I did extend it the entire length of my graph, which is good. And now the other thing I have to do is think about shading. So again, looking at my symbol, I have y is greater than. Greater than is better than, is more awesome than, is above. So I'm going to shade everything above my line. And that is your answer for each of those two graphs. Okay, so here we have a lot more graphing. We're going to look at each of these and we're going to identify what's happening, what type of transformation. So let's look at the first problem, number 7. I'm going to graph this thing. I look and first identify my vertex. Let's start with purple. So I have my vertex. My vertex is going to be 0, because there's nothing inside with my x, 3. So 0, 3. There's my point. Now what I'm going to use next is my slope, which is -5, or -5/1. So from my vertex, I go down 1, 2, 3, 4, 5/1, and I put a point. Again, down 1, 2, 3, 4, 5/1, and I put a point. Now I need to reflect those. So I'm going to go over here, put a point, over here, put a point. And now I'm thinking about how I'm going to connect these dots. Well, if you look at the type of problem we have, I see all equal signs. So what that means is I'm not doing any shading. All I'm going to do is connect my dots, and I'm looking at the graph with no shading, no inequality symbol. So this is the picture that I have. Let's talk about what happened. Did I move left or right? Well, looking at my vertex, did I move left or right? No, I didn't. But I do see from the origin, I had to go up 3. So I could write here that I went up 3. Now the other thing that happened is I have a slope here that's not 1, it's -5. Now all that negative does is it flips it so it's upside down. Okay, but the 5 part of it is what's important. That 5 part of it stretches my function out, which means that I have a stretch by 5. So that's that problem. What I'm going to do is I'm going to leave all of my writing there, and I'm going to just switch to a different color. But I feel like the graphing will get confusing. So let me see if I can get rid of just this graph here. It doesn't seem like it's going to let me get rid of those points. Oh, let me try again. There, I can get rid of those points. And can I get rid of that point? I can't get rid of my vertex. So let's just keep moving. I'm going to look at my next problem. I'm going to switch colors for you. Now we're going to be using red. So here I see my vertex. Well, there's nothing inside with my x, and there's nothing at the end. So my vertex is just going to be at 0, 0. So remember, we're focusing on the red points right now. My vertex is at 0, 0. I use my slope, which is 3. Go up 1, 2, 3/1. Up 1, 2, 3/1. Then I reflect. And I connect my dots with nice long lines with arrows on the ends, and I have my graph. Ta-da. So if I think about it, did I move left or right? No. Did I move up or down? No. My vertex is still right there at the origin. I haven't gone anywhere. So the only thing that's happened is I have this slope of 3. So what that means is I stretched by 3. Okay, so let's go back. I'm going to try to delete some of this stuff again for you. And then we are going to move on to the next problem. Let's use green now. So for number 9, I identify my vertex. -3, -4. I place that point, -3, 1, 2, 3, -4, 1, 2, 3, 4. Right there, -3, -4. I use my slope. Well, my slope is invisible. It's that 1. So up 1/1, up 1/1. On the other side, I'm going to reflect, and I connect my points with nice long lines with arrows on the ends. And there's your graph. Did I move left or right? Well, from my origin to get to my point, my vertex, I moved left. I moved left by 3. Then, after I moved 3 left, I also had to go down 4. So, down 4. And because my slope was 1, I did not have any stretch or compression. All right, so again, I am deleting that graph, and now we are going to switch to blue. Okay, so number 10, I have my vertex. It's going to be positive 3. Remember, we always switch that sign from the absolute value, negative 5. Positive 3, negative 1, 2, 3, 4, 5. Right there's my vertex. My slope, again, is 1, so up 1 over 1, up 1 over 1, reflect, and then connect your lines. Nice long lines with arrows on the ends. Don't forget your arrows. Those are very important. And that's my graph. Now if I think about how it shifted from my origin to get to my vertex, I had to move right by 3, down by 5. So my shifting was right 3, down 5. Okay, let's move on to the last one, number 11. We're in orange now. My vertex, I take the opposite of that 5. What's on the outside? Nothing, so 0. My vertex is negative 5, 1, 2, 3, 4, 5, 0. So there's my vertex in orange. My slope again is 1. Up 1 over 1, up 1 over 1. Reflect. Connect my dots. There's my graph. In order to go from my origin to my vertex, I had to move left 5. Did I move up or down at all? No, I'm right there. So all I've done is I moved left 5. I didn't stretch or compress because, again, my slope is just 1. So that is all that I did. So for 12 and 13, we're looking at transformations again. When you're looking at transformations, I want you to be asking yourself 3 things. 1, did I move up or down? I may have moved up, I may have moved down, I may not have moved up or down at all. 2, did I move left or right? I may have moved left, I may have moved right, I may not have moved left or right at all. And 3, did I stretch or did I compress? I may have stretched, I may have compressed, I may not have stretched or compressed at all. So now there's certain ways to identify these things simply by looking at the function itself. There's going to be particular places to look. So for up or down, I'm looking for something that was just tacked on at the end. That's what I'm looking for, a number that's just tacked on at the end. For left-right, I'm looking for a change within parentheses or absolute value bars. And then for stretch and compress, I'm looking for my slope or a number multiplied through. All right, so let's look at number 12 here. Number 12. I start with f of x, which is just x squared, and I end with g of x minus 2 squared plus 8. Now, I talked to you in class about these games, right, where you have to find the differences. So your task is to find the differences. First thing I see, I've got this plus 8 at the end. It's just tacked on out of nowhere, tacked on to the end. Well, tacked on to the end means that's going to be an up or down shift. I know because it's plus 8, I'm going to be moving up by 8. The other difference I see is this minus 2 inside parentheses. So because there's a change within my parentheses, I know I have a left or a right shift. Now be careful though, because yes, it's a -2, so that makes me think I should be going left. But within your parentheses, it always is going to be the opposite of what you think. So I really went right 2 units. So I went up 3 and right 2. I'm sorry, up 8 and up right 2. So my next example I'm going to look at, I see I started with 3x squared and with 12x squared plus 2. Again, I just have this random plus 2 tacked on at the end. So that tells me I'm going up by 2. The other thing I noticed is that I went from 3x squared to 12x squared. And the way that happened is I went from 3 to 12 by multiplying by 4. Now if we think about it, multiplied through, a number multiplied through. I multiplied this whole thing by 4. So because I multiplied, I know I have stretch or compress. Now we have to think stretch or compress. For stretch or compress, a number greater than 1 means a stretch. I don't care about the negative. I don't care if it's negative or positive. It's only the number itself, not the symbol. Number less than 1 is compress. So in this example, I multiplied by 4, which means I have a stretch by 4. All right, numbers 14 and 15. I need to find the function rule. So this time, they're giving me my f of x, and they want me to write my g of x. In number 14, translated 4 units right and 8 units up. So I'm going to say g of x is going to be some function similar to this one. Whoops. Similar to this one, x squared. But I need to make some slight changes. Up 8 units means I'm just going to have a plus 8 tacked on to the end. So that's easy. Right 4 units means I need to have some change within parentheses. So here where I had x squared, I'm going to have x squared, but I need to make some change within my parentheses. Right 4 units means I'm putting minus 4. Remember, it's the opposite of what you would think. Minus 4 is really right. And then in this last problem, I want y equals x, but I want a vertical stretch by a factor of 2. A stretch, remember, is just multiplying a number through. So y equals 2x is your answer. All I did is multiply 2 times my x, and that's it. Now here, this is the short answer part. I give you some values here. It says the table displays the amount the Bush family, that's Mrs. Bush across the hall, spent on pizza during 2004 through 2010. So they're buying a lot of pizza because check out these costs. I've got 400, 500, 375, 200, 225, 175, 100. It appears to me that their prices are going down, which is good. But what I need to do is I need to graph this information. So on my x-axis, I'm going to put 04, 05, 06, 07, 08, 09, and 10. It's a little bit difficult to read, but I'm going to label my axes. Now, on my y-axis going up, I'm going to do, I don't know, maybe like this little line break thing. Remember this squiggly thing I said you can use so you can start at a higher number? And then, let's say 100, 150, 200, 250, 300, 350, 400, 450, and 500. And then 550 is this top line. Okay, so I've got my numbers put in there. Now what I need to do is I need to create a point out of each of these sets of values. So I'm going to have 1, 2, 3, 4, 5, 6, 7 points that I need to plot on here. All right, let's choose orange. So my first point is going to be 04, 400. So I go to 04, I go up to 400, and I put a point. Then I have 05, 500. 05, 500, put a point. Next one is 06, 375. So that one's like halfway in between our lines. It's not perfect. Next one, I just did 06. Now I'm on 07, 200. So 07 is here up to 200. And I put a point. Next one is 08, 225. Here's 08. Here's 225. So I put a point. 09, 175. 09, 175. And then 10 is 100. So that's part A. I've made a scatter plot of the data. Then part B says, if one exists, draw a trend line. Does it appear that my points here have some sort of trend to them? These points, do they have some sort of trend? I believe so. So I'm going to go in, and with a red line, I'm going to just kind of sketch a trend line that kind of goes through the middles of those. That's approximate. It doesn't have to be perfect. Maybe it would be a little bit more to the right. Maybe it would be a little bit more this way. You know, it's going to be an approximate thing. But that's my trend line. That's my trend line. You should draw one similarly into that. And then 17 says, estimate the amount the Bush family will spend on pizza in 2012. So if I were to continue this, this would, let's see, this is 10, this would be 2011, this would be 2012. So if I kind of look at this and I extend my trend line, I think my trend line might be a little bit off. Let's draw another one in green. Maybe this one will be closer, I'm not sure. Maybe it needs to look, oops, that was supposed to be green. Maybe it should look a bit more like that. Not sure. I mean, it's going to be close. But if I look at 2012, they're spending like no money either way. If I look at the red one in 2012, it's like way down here is where they would meet. And my green one, 2012, they would still meet down here. So I'm going to say that they would spend, $0. Okay, that would be my estimate. Now it says describe the correlation. I know that this is going to be a negative correlation because if I look at the slope of my trend line, either one of those lines, the red one or the green one, because they're a little bit inaccurate, either one of them, though, is negative. The other thing we can talk about, though, is what this actually means, right? And if I think about what it means that as the years go on, Miss Bush is getting much healthier. She's not eating as much pizza. Either that or she's just finding really cheap pizza, and she used to be spending a fortune on, like, gourmet pizzas. I guess either one of those could be true, but I'm going to say that she's just not eating as much pizza. So for this slide, it's asking us similar questions. It's asking us to determine the type of correlation for each. So if I think about number 18, it says a person's height and the number of shoes he or she owns. Does a person's height have anything to do with the number of shoes he or she owns? I don't think it has anything to do with it whatsoever. So I would say no correlation. Some people like to have a lot of shoes, some people don't. If you're short, you can still have a shoe fetish. I'm pretty short and I love shoes. Miss Bush is pretty tall and she loves shoes. So your height has nothing to do with the number of shoes you own. 19, time in years, total human population. So if you think about, as the years go on, what is happening to our human population? As the years go on, our population is getting larger. So I would say that this has a positive correlation. As the years go on, our population is getting larger. So it looks something like this. This would be years. This would be the population. And as the years are going on, our population just keeps growing. The last one is the distance you drive and the amount of gas in your car. So as I'm driving, my gas is getting lower. The little needle is moving to the empty, right? So as I'm driving, the amount of gas that I have starts out pretty high. I have a full tank, and it's just slowly going down. This is the amount of gas that I have. Starts out fairly full, right? Say, I don't know, I have 40 gallons in my car. That's way too much, I'm sure. But I start out full, and then I'm driving, and I'm losing gas slowly. So this would be a negative correlation. Okay, so that's the entire packet. Please make sure that you study some more, go back and through this. If you need to pause or rewind or fast forward, whatever you need to do, please make sure you study because this will be the last major grade before the report cards. So good luck. I will see you tomorrow in class. If I have you 5th or 7th, there will be a sub. I will not be there. Remember, you will not have a calculator for this test, but please make sure you study and do your best. I look forward to seeing you next week. Have a good weekend.